Hello students, let us solve one HOTS problem based on topic similarity from maths part 2. So that diagram is given and the question is, in this diagram there are two triangles given. It is triangle ABC and triangle DBC. For these two triangles, they have a common base, that is BC is a common base for both of these two triangles. From this one we have to prove that area of triangle ABC divided by area of triangle DBC is equal to AO divided by DO. So here we can see AO and DO. We have to prove that the ratio of areas of these two triangles is equal to ratio of AO and DO. So for this one we have to do one construction. We have to draw a perpendicular from point A to the base BC. So let it be AM. So AM is perpendicular to BC. In the same way, for the second triangle DBC, also we have to draw a perpendicular from point D to its base, that is BC. So let that perpendicular be DN. So as we have drawn here two perpendiculars for two triangles, now this time segment AM is perpendicular to segment BC. That means AM is the height of triangle ABC. In the same way, segment DN is perpendicular to base BC. That's why DN is the height for triangle DBC. So this time we must understand what is height of a triangle. So for a triangle, a perpendicular drawn from a vertex to the base is the height for that triangle. So for these two triangles, AM and DN are the heights of these two respective triangles. So this is the construction we have done. Segment AM is perpendicular to segment BC and segment DN is perpendicular to segment BC. Now due to these two construction, we have got two triangles, triangle AMO and triangle DNO. Now we have to consider these two triangles and we are going to try to show that these two triangles are similar. For these two triangles, angle AMO is congruent to angle DNO as each of 90 degree, because we have done a construction that is AM is perpendicular to BC and DN is perpendicular to BC. That's why measure of these two angles are 90 degree. Now there is another constituent, angle AOM and angle DON. These two angles are vertically opposite angles and vertically opposite angles are congruent. That's why angle AOM is congruent to angle DON, and the obvious reason is vertically opposite angles. Now for these two triangles, we have two angles of one triangle are congruent to two corresponding angles of the another. That's why these two triangles are similar by AA test. So triangle AMO is similar to triangle DNO by AA test. And we know that if two triangles are similar, then their corresponding sides are in proportion. So if we write the corresponding sides, it is AM, its corresponding side is DN. So these corresponding sides are in proportion. That means AM divided by DN is equal to the second corresponding side is AO and DO, that is equal to AO divided by DO, that is equal to MO divided by NO. So these are the corresponding sides and they must be in proportion. That means we can write here AM by DN is equal to AO divided by DO is equal to MO divided by NO. And the reason is corresponding sides of similar triangles. We'll name this as equation number 1. Now we have to consider the ratio of areas of these two triangles. Now it is given that for these two triangles, base is a common, and we have the property that for two triangles, if base is common, then the ratio of their areas is equal to the ratio of corresponding heights. So from that we can have area of triangle ABC divided by area of triangle DBC is equal to AM divided by DN, as AM and DN are the heights of these two triangles. And the reason is triangles having similar base. And the reason is triangles having the same base. Now here, instead of AM divided by DN, we can write AO divided by DO, because in equation 1 we have proved that AM divided by DN is equal to AO divided by DO. That's why area of triangle ABC divided by area of triangle DBC is equal to AO divided by DO. This is from equation number 1. So that is we wanted to prove area of triangle ABC divided by area of triangle DBC is equal to AO divided by